Hello everyone. We are going to see a little bit about what linked lists are, especially what a singly linked list is, and how to write a program on singly linked list in C programming language. Okay, so these are the some of the contents, some of the topics that we are going to see in this particular short video. We are going to see what a linked list means and what are the basic operations on a linked list, and we are going to see how to insert an element into a list, how to delete an element from the list, and how to traverse the list. Introduction. Here comes the main part. So, what a linked list is. Uh, we can use linked list, a general term linked list, uh, with another name called singly linked list. In general terms, a linked list always means a singly linked list. So a list is composed of a number of nodes in which each node has a next pointer to the following element. This this small representation shows here a small node. A node looks like this, where it has a value called data and a pointer called next, which points to the next element. So a list is composed of a lot of nodes which are connected together with the help of this next pointer. So as you can see, this is a representation of a small list which contains 4 nodes: node 1, node 2, node 3, and node 4, and each has a pointer here which points to the next element. This pointer points to the next element. This pointer of 7 points to the next element. This pointer of 40 points to something else. Now this is an important node because this node has a pointer which is pointing to null. So whenever you see a node whose next pointer points to null, represents that this is the end of the list. That means this is the last element of the list. And here comes a small type declaration of the node that we have just seen. This is a node element, and we are calling this node as list node, and this node we have uh, uh, declared as a structure in C language. So this particular list node structure contains a variable called data, which is of type int, so representing that this data will be of integer values. So as you can see the example here, 4, 15, 7, and 40 are integer values. And there comes the next pointer, which represents it is of type list node, which is a structure in turn. So basically this next pointer is capable of pointing to another element of types list node. So each node of this particular list is comprised of this list node nodes. Every single node here is a list node. So these are the 3 basic operations on a list that we can perform. First one is traversing the list. Traversing means going through all the elements in the list from start to end. This process can be extended further to display all the elements of the list or count all the elements of the list. The second important operation on a list, is inserting an element in the list. The third operation is deleting an element from the list. Now, this traversal, the first operation that we have seen, can also be used as an auxiliary operation in insertion and deletion, and that is what we are going to see further in the next few slides. So, the next step is traversing a linked list. So these are the 3 steps we must follow to traverse a linked list. The first step is follow the pointers. That means pointer here represents the next element, next of a particular element. So follow the pointers. We have to take the next pointer of a particular node to go to the next node and then display the content of the nodes, display the content and then move to the next element, and so on. Stop when the next pointer of a particular node points to null. So here, if we consider this particular example, we will start from 4 because start is the first pointer, and then this is pointing to 4. So from here onwards we will go, first we print 4 and then we will go to the next pointer of this node, which will lead to 15. We will print 15 here, and then we will go to the next pointer of this 15, which will point to 7, and we will print 7. After that we will go to 40, print 40, and by the time we reach 40 we will realize that the next pointer of this 40 points to null, which according to the list uh, declaration that we have seen in the previous slide tells that this 40 is the last element of the list, and so we need to stop here, and so stop when the next pointer points to null. So here is a function called list length, which counts the number of nodes in the list. The function given here uses a pointer called current, which is at first pointing to start, and we are maintaining a variable called count, which is currently having a value 0 at the start. So we will be using these two variables, current pointer, which is of type list node, and a count variable of type int, to maintain the count of the nodes that are present in this any particular list. So as you can see, we are having two variables, current and count, and this current is pointing to the first element here, first node here, which is currently pointed by start, and currently count is equal to 0. Let us go through this function and let us have a walkthrough of this function to find out how this function gives us the count of the list. So here, as we have seen, now current is pointing to the first node and count is equal to 0. So it is saying while current is not equal to null. So the current currently is not pointing to null, as we can see that it is pointing to a element of list node which contains a value 4. So we are saying count increment. So the count value becomes 1. So now current is still pointing to 4 here, and count has become 1. Now we are saying that the next step here is current should start pointing to the next of current. That means the current next of the next pointer of this current is pointing to the next element. So we are saying let us make current point to the next of current. So we should make this current point to the element which is currently being pointed by next of current. So we have to disconnect this and make the current start pointing to this. Okay, so after that it goes back to the loop condition checking and checks whether current is now pointing to null. Let us see, current is not pointing to null. So it goes inside the loop again, count gets incremented, and count becomes the count becomes 2, and now again we are saying current should start pointing to next of current. So the next of current is here, which is pointing to this element. So we have to disconnect this and make current start pointing to this element. Okay, so now again it checks whether current is not equal to null. Of course the current is not equal to null, so we have to increment count, and count becomes 3. Now again it checks whether current now once the current is incremented, again current becomes the next of current, so we have to disconnect this and make current start pointing to the next element. So now current starts pointing to this. Now again we are checking whether current is not equal to null, So current, as we know that it is not pointing to null, it is still pointing to some element. So again, we have to increment the count. So count becomes, as you guessed, 4. And now again we have to make current point to next element, next pointer of current. So next of current is currently pointing to, as you can see, this next of current is pointing to null. So when we say current point to null, sorry, current point to next of current, so basically current starts pointing to null. Okay, so when current starts pointing to null, the next step after this is it goes back to the while condition checking and checks whether current is pointing to null. Yes, of course, current is pointing to null. Because current is pointing to null, this condition does not get satisfied, which checks whether current is not pointing to null. So this condition does not get satisfied, and so it just comes out of the loop and it returns the value of count, which is currently 4. So the total count of this particular list given here is 4. So this is how we traverse a linked list, especially a singly linked list. This ends the current video, and in the next video we will see how to insert an element into a linked list. Thank you.